We shall start as we have already delayed about 15 minutes. So very good afternoon to everyone. Greetings to all on behalf of the Technology Enabling Center, Mizoram University, DST team. And we are very privileged to have Dr. Biswajit Ghosh in our midst as a resource person. I believe that this session will be a fruitful one as far as research work is concerned. And there will be a Q&A session at the end. So I would like to request you, if you have any questions, you may jot down on your notes or digital notes or whatsoever. And then we'll have an interactive session at that later stage. And please don't hesitate. There is no too small or too big questions. So you can ask anything related to statistics, which can be useful for your analysis or your research work concern matters, right? Now, without delaying much, let me invite Dr. Lantingliana Rentley, our organizing secretary, to have a few words. Then once he's done,
hello, am I audible?
And hand over the session to our resource person.
Yes, you're audible,
Hello.
sir.
Hello, sir. Am I audible?
You are audible. Okay, thank you so much, Sir Efrain. A very good afternoon to everyone. A respected resource person for today's workshop on statistical techniques for social science, Dr. Biswajit Ghosh, Assistant Professor, Department of Commerce, Tezpur University. Coordinators and staff of TEC, Technology Enabling Center, MZU, our sponsor for today. The co-coordinator of the workshop, Mr. C. Efrain, faculty members of management department and other departments of MZU and other universities, dear participants, ladies and gentlemen. I, on behalf of the team, would like to extend a warm welcome to everyone this afternoon. Well, as you can see in Aizawl, it's raining quite heavily. And I think for most areas around Northeast, you might also be experiencing the cool weather today. I would first of all like to thank all the participants, our esteemed participants, for registering and attending this workshop on statistical techniques for social science, which is the need of the hour for every researcher, academician in their research work. I'm so grateful for the overwhelming response that we have received in such short notice. So I'd like to thank all of you and like to welcome all of you for today's workshop. I would also like to extend a warm welcome and thank our sponsor for today's workshop, TEC, the Technological Enabling Center, Mizoram University. And I would like to take this opportunity to tell something about our sponsoring Technological Enabling Center today. Well, Mizoram University established Technological Enabling Center, which is funded by DST in the year 2019. Mizoram University TEC is a satellite center under the mentorship of Tezpur University, Assam. Well, the goal of DST TEC is to foster an ecosystem for training and technological transfer and to concentrate on the mining of technologies present in the host and partner institutions. Well, TEC will strive to create an ecosystem for technological development in the universities and provide a platform to network researchers with other institutions as well. TEC also has a vision of aiming at bridging the gap between technological development and also technological transfer. TEC will also enable the industry, academia to connect and work together. TEC will also, focuses on mandatory part of universities with industries and national research laboratory. And here in Mizoram University, the center is constituted by a very efficient and motivated team with Professor V. Ratnamala as our coordinator from the Department of Mass Comm. We also have Professor N. Senthil Kumar, our co-coordinator. Then we have Dr. Baby Zaikhan Puigmar as our coordinator from the Department of Food Technology. We also have Dr. Rajesh Ramasamy from the Department of Tourism and Hospitality Management as our co-coordinator. Then we also have Dr. Lalming Liana, Assistant Professor from the Department of Computer Engineering as our co-coordinator. And our center is also, fortunate to have Mr. Sila Rinsanga as our project associate at TEC, and also Mr. Isak Laltranpuya as a field worker here in the center at MZU. So I would like to thank our sponsors for today's, workshop. Now, I'd further like to take this, opportunity to welcome our resource person for today, Dr. Biswajit Ghosh, Assistant Professor from the Department of Commerce, Tezpur University, who has a lot of experience in research. Well, Dr. Biswajit Ghosh, who is a former colleague of ours here at MZU in the Department of Management, a very good friend of mine, a person who is humble and down to earth. Now, let me tell you a little bit more about our resource person. Well, Dr. Biswajit Ghosh is currently serving as Assistant Professor in the Department of Commerce, Tezpur University, and previously he has worked in Mahatma Gandhi Central University in Bihar and also Mizoram University in Mizoram. He has joined Tezpur University in the month of December 2019. He has received his MCom, PhD degree from Guwahati University and Eastern Hill University, respectively. He has a teaching experience of about 6 years in 3 central universities. His area of specialization is accounting and finance. Now,
Yes,
Is it
yes, it's coming.
visible?
Yes, sir. It's coming.
I think it is in presentation mode, right?
Right.
Okay. Thank you so much once again for the opportunity. So I'll start with the topic. Though the title of the topic is Statistical Techniques for Social Science Research, before going into the technique, I'll just try to give some background about the statistical analysis. Why that background is important, I just felt that since it is for the social science research and researcher, and apart from commerce and management faculties as well as scholars, I think there will be scholars from other social science department like history or education or any other background where the statistical background is not much. So that is why I thought let us first discuss about some basic things about statistical analysis, and then I will give you an overview of some of the important techniques that we can use in our research. Not going into very much technicality about those techniques, because we can do these things with the help of software these days. But we need to know about their use, their application, as well as some of the assumptions that needs to be fulfilled if we want to use some specific statistical technique. So with this background, let me start or show you the contents of today's discussion. So these are the things I'm going to discuss today, if the time permits. So we'll start with the meaning of statistical analysis here. Statistical analysis, as you can see, it is a method used in research to analyze and interpret data collected from a sample of a population. So most of the time what we do, we try to study a population, but since the collecting data for the entire population is difficult, we go for sampling, and based on the data collected from the sample, we try to infer about the population. Now, statistical analysis is the method by which we can analyze the data that we have collected from sample, and based on that, we will talk about the population. It is a powerful tool that enables researchers to identify patterns, relationship, and trends within the data, and to draw inferences about the population from which the sample was drawn. So once we collect the data, then next thing comes that we want to study that data, okay, investigate the data. So with the help of these statistical techniques, we can identify if there is any pattern, if there is any kind of relationship between or among the data, or if there is any kind of trend in the data. And by doing that analysis, what we try to do, draw a conclusion about the whole population that is there behind this study. Okay, now what is the importance of this statistical analysis? The one that I have already said, one or two. The first one is drawing conclusion from the data. We want to infer something about the whole population, but we are not collecting data from the entire population. We are collecting data only from some part of the population, which is called sample or sample units. So based on the analysis of that sample units, we want to infer or draw conclusion about the whole population. So statistical analysis gives us that power to do that. Identifying patterns and relationship. If our data is showing any kind of pattern, trend, or relationship, that can be assessed with the help of statistical technique. Improve research design. That is very important. This statistical analysis help us to design some kind of for our research we can go for a design with the help of statistical analysis or statistical technique that is more solid or more concrete. It gives us some kind of direction by which we can fulfill our objective. So for example, one very simple example, if we think about in our research, many times we have a tendency to formulate some kind of hypothesis. Most of the studies we try to formulate some kind of hypothesis based on the theoretical expectation. Now, this statistical, one of the key issue in formulation of hypothesis is that should be testable. We should be able to test the hypothesis, otherwise we cannot formulate any kind of hypothesis. Now, for this testing of hypothesis, we need some kind of statistical tool. So if we want to follow a design statistical research design where do we want to formulate hypothesis related to our objective, then in that case we must need to use some kind of statistical technique by which we can test the hypothesis, whether our hypothesis is true or false. That has to be tested, and statistical analysis helps us to do that. Then making prediction. There are some statistical techniques by which we can predict about the future. Say for example, time series analysis, if we see, then with the help of that kind of analysis, what we can do, we have data for the past and present, and based on the analysis of those data, we can predict what is going to happen in future. Say for example, if in a business structure, if I give one example of business, then say for example, we have data for last 20 years or 30 years about our sales, how much sales we are revenue we are generating in our business. Now by analyzing this last 20 years or 30 years data, we can also predict what will be the sales, say for example 5 years from now. So that kind of thing is possible with the help of this kind of statistical technique. Then validating findings. By using statistical method to analyze data, researcher can demonstrate that their findings are not just due to chance or some random this thing. Because when we are testing hypothesis, we also make sure that the results that we are getting, it is not because of the chance. It is not like that we have got some results by chance or because of pure coincidence. We make sure that the results that we are getting, that is systematic and that is valid, not because of chance. So these are some of the importance of statistical analysis, and because of which we often get the temptation to use some kind of statistical technique in our research. Now, what is the process of statistical analysis? Or before we go into the technique, what is the whole process? The process starts with the data collection. The first step involves is we need to collect data related to the study that we are going to do. So data collection, there may be many different techniques of data collection. We will not go into that. It may be primary data, it may be secondary data. If it is primary data, then we can go for, say for example, survey. We can go for some kind of experiment. So there is different methods of data collection. We will not go into that. Once we collect the data, we should not jump into applying some kind of statistical technique. Before that, we need to follow certain other steps like data cleaning and preparation. Once we collect data, we may find that some of the data there is no consistency. So what to do with those data? We may also find that there is some kind of missing data. Say for example, if we have collected from data from 200 people related to 50 questions, say for example. Now some of the questions they have answered, some of the questions they have not answered. There may be some kind of missing observation. What to do with those data? Then there may be some outliers also. Say for example, if you are collecting data for the income level in a particular locality, and if you find that most of the people out of 100 people or 100 respondent, 95 of the respondents, the income is ranging between 10,000 to 50,000, but 5 of the respondents, they are having very high income, say for example 2 lakhs or 3 lakhs, which is much higher than 10,000 to 50,000. So those 5 people, they are kind of outlier in the context of your study. So what to do with those data? So the second step is data cleaning and preparation for the analysis. Okay. Then the third stage is exploratory data analysis that involves descriptive statistics and data visualization technique to explore data and identify pattern, trend, or relationship. Before we go into apply in, I mean, any kind of sophisticated statistical technique, we need to also see what is the pattern in the data that we have collected, because we'll see in our next few slides that there are certain assumptions need to be fulfilled when we think of applying some kind of statistical technique. So related with regard to the data, now whether our data is fulfilling those assumptions or not, we need to visualize those things. So we need to explore the pattern in the data. Say for example, one very common thing you must have heard, all of you, say for example, data has to be normally distributed. Now whether the data is normally distributed or not, that we need to check before we apply any kind of statistical technique, because depending upon that, our statistical technique will vary, what kind of statistical technique we can apply. So exploring the data that we have collected. Once we finish these things, then we go for applying the appropriate statistical tool for the purpose of our hypothesis testing. That may involve comparing mean, testing of correlation or association, or conduct any kind of regression analysis depending upon the objective of our study. But before going into these things, we need to ensure that data fulfills the underlying assumptions for the behind those tests that we are intending to apply. So once we apply those tests, we get the result. Then the next thing comes interpretation and drawing conclusion. Once we get the results, we need to interpret those results, and we need to draw a conclusion based on those results. So that involves making recommendation or proposing for further research. So just getting the result and reporting the result is not sufficient. Once we get the result, we need to interpret those results, and then based on the interpretation and based on the results, we need to draw some conclusion with respect to the hypothesis that we have formulated, whether our hypothesis is accepted or rejected, if it is accepted, what is the theoretical argument behind that? If it is rejected, what can be the theoretical argument behind that? So like that, we need to interpret the results, and then we need to draw conclusion based on the results. And the final step is, for any kind of research, we need to report or present the results. That reporting, maybe we can write a research paper, we can make a presentation in the seminar or conference, or any other kind of, we can write a thesis or any kind of policy document, whatever it is, depending upon the objective of the study. But we need to present the results to the audience, okay, which is the ultimate purpose of all this kind of analysis. So this is the whole process of statistical analysis. Now there are certain difficulties that we may face when we think of applying any kind of statistical technique. These are some of the difficulties, some common difficulties that we may face. So for example, the first one is data quality. Once we collect data, we never know what kind of data we'll be getting from the field. Though we make so many plans regarding the way that the data will be collected, but there may be always some kind of uncertainty, and that may affect the data quality. So for example, if the data is in conflict, so we have approached many respondents, but most of the respondents did not bother to reply or to answer to our queries or provide data. They may have provided data, but that may be inaccurate. They did not give us correct data. That we cannot again, we have to find ways to to be sure that the data is accurate. Or it may be biased also. The kind of data that they have provided, that may be biased in the sense that that is affected by their personal opinion or something like that. So that will create a problem in our statistical analysis. Then data complexity. In some cases, the data can be complex, making it challenging to analyze using statistical method. That the nature of the data may be such that we may find it difficult to apply any kind of statistical tool. So that is why when we prepare our plan for research, if we are thinking of testing, formulating hypothesis or testing hypothesis, we need to think about the source of data and the kind of data that we'll be getting from the field or from any of the secondary sources, so that we can apply appropriate statistical technique for the purpose of analysis. So that kind of complexity we should try to visualize beforehand. Then sample size. If the sample size is too small, the results may not be statistically significant. That is another aspect. Many of the advanced statistical techniques, they demand a larger sample size. Now, if the sample size is too small, those techniques cannot be applied. Even if we try to force to apply those techniques in a sample size which is smaller in a sample which is smaller in size, we may not get significant results or appropriate results as per the theory. So that is a practical problem. Now, in order to solve this problem, what we can do, we can go for a large sample. Now, if we go for a large sample, then again there may be a problem like we have limited time, we have limited financial resources. So we need to maintain a balance, and that sometimes become difficult. When we see that we are facing problem in terms of publication or writing good research paper, one of the reason is this: we cannot go for large sample because we have limitation of time and resources. And when you go for a small sample, we find difficulty to apply appropriate methodology which can give us good results or appropriate results. Next is assumptions. Many statistical methods rely on specific assumptions about the data being analyzed. So we'll look into that. If these assumptions are not met, the statistical analysis may produce unreliable result. So that is very, very important. I feel that the whole idea of understanding the techniques, which kind of technique we can use for the purpose of analysis of our data, those assumptions we need to check very, very carefully whether those assumptions are being fulfilled or not. If the assumptions are not fulfilling, then we should not force some kind of statistical technique for the data set. Interpretation. Researcher may require expertise in statistics to understand and interpret the results. I have seen some examples during my last few years experience in the field of research, that many a times we get the information, okay, get the results, but then after getting the results, we do not know how to interpret those results because we do not have that required expertise in statistics to understand and interpret the results. So that is why calculation is not very difficult. Okay, statistical technique, if we want to use in our research, the calculation is not very difficult because everything is done by the software these days. But then the background of the technique that we are using, that has to be very, very clear to us, because the interpretation, we can only do proper interpretation of the results if we have the idea about the technique that we are using. Time and resources. Statistical analysis can be time consuming and requires specialized knowledge and resources maybe. So that is another aspect. It is time consuming because we need to learn these things, and then after learning also, when we try to actually implement the technique in the data set that we have collected, we will find many problems because the data may not be matching with the the technique that we are applying. So we need to play with the data, and that requires a lot of time. First collecting the data, then arranging the data, preparing the data for the purpose of analysis, and then when we try to actually analyze, we may find that again it is not giving appropriate or results the way we have expected. Then accordingly we need to see some other alternatives. How can we modify the data or increase the data so that we get desired results? So that requires a lot of time and resources. So these are some practical difficulties we face. Some of the precautions also we need to take before we go for applying statistical techniques, like appropriate sampling technique. Researchers should ensure that their sample is representative of the population that they are studying. Now, since we use statistical analysis because we want to conclude about the whole population based on the sample data that we have collected. Now, say for example, if I talk about the entrepreneurs in the northeastern region, now there will be thousands of entrepreneurs. Now I cannot study for thousands of entrepreneurs. What I am trying to do, say for example, I'm collecting data, I'm selecting 200 entrepreneurs, and based on those 200 entrepreneurs, the data I'll be collecting, and based on the analysis of those results, I will be concluding about the whole set of entrepreneurs who are doing business in the northeastern region. Now that is a very risky task, because if I do not collect those 200 entrepreneurs systematically, then I may come up with a conclusion which is not applicable for all the entrepreneurs in the region. So that is why when we go for sampling, we should ensure that the sample that we are collecting, that is representative of the population that we are studying. Otherwise, the whole purpose of analysis will go in vain. Then there should be appropriate statistical technique to reduce bias. Many of the statistical analysis, they assume that the data is collected by simple random sampling, because when we apply simple random sampling, what happens, the chances of biasness gets reduced. So if we go for convenience, then I will go as per my convenience. Say for example, whoever nearby, all the entrepreneurs who are nearby me, I'll be collecting data from them, but that will be biased. Okay, so appropriate sampling is very, very important. Data quality, we have to make sure that the data is of good quality, it is accurate, it is complete, there is no outlier, and if there is any missing data, we are finding appropriate ways to deal with those missing data. And then the data that is collected, that is actually relevant or related to the question that we are trying to answer in our research. Then valid statistical tool. There are many different tools for analysis of data, so we have to select the tool appropriate, I mean tool for our purpose, very, very carefully. Okay, so researchers should use appropriate statistical methods that are valid for the type of data being analyzed. They should ensure that the statistical assumptions are met before conducting the analysis. Then transparent reporting. Researchers should report their statistical analysis methods and results in a transparent and clear manner. Whatever technique we are using, those techniques we should report clearly. Okay, small details we should try to report. Say for example, in regression analysis, many a times we use say for example, if I'm using any kind of panel data regression analysis, then in that regression there is fixed effect. Say for example, fixed effect model, I'll just for example or understanding, I'm saying say for example, there is fixed effect model. Now in fixed effect model, we can control the impact of say for example time, we can control the impact of subject or panel specific heterogeneity. Now whether I'm actually controlling or not, I should report that when I'm reporting my results. These small details which are critical in nature, those should be reported. Why I'm giving this example, recently I mean I came across that kind of situation where someone used what you call fixed effect model, but then whether the time effect is controlled or not, that was not reported. Now since that was not reported, it was giving an impression that in this particular research, time effect should be controlled, otherwise result will not be appropriate. So when the question was asked to that researcher, he replied that yes, time effect was controlled, but then it was not reported. So that may give an adverse impression, like whether your result is appropriate or not, or whether there is anything lacking, that something was needed to be controlled that was not controlled. So if you have done the thing in your analysis, you should try to report that. That is transparent reporting. Okay, the final one is review by experts. Especially for us, like social science researcher, what happens that no matter how much we try these techniques and all, these are we are taking from other domain like econometrics or statistics. So many a times small things we may miss. So it is always better that when we are applying some kind of statistical technique, we should take the opinion of the experts in that particular field. So that will always improve the results, that will always improve the quality of our research. So these are some of the precautions we should try to take. Then the next thing is types of statistical analysis. There are different types of statistical analysis. This is not an exhaustive list. we can keep on adding into this list, but these are some of the very common types of statistical analysis we do in our research. The first one is descriptive statistic. What is this descriptive statistic? This is no, descriptive statistic is something which shows or which tells us about the characteristics of the data that we have collected for the purpose of our research. If you have collected data from 200 respondents, what is the characteristics of that data set? So the type of analysis involve summarizing and describing the main features of a data set, such as mean, median, mode, range, standard deviation, or variance. Okay, so when you have collected the data, before we go into applying some kind of technique for the purpose of hypothesis testing, we need to understand our data set. So descriptive statistics is the tool by which we can analyze our data in order to understand the underlying characteristics of the data. What is the mean of the data, median of the data, what is the variation in the data set? Okay, those things we can understand with the help of descriptive statistics. Next comes the most important part, that is inferential statistics. Inferential statistics are those statistical tools which are used to test the hypothesis. That means which are used to draw conclusion about the population based on the data collected from the sample units. Okay, this type of analysis involves making inferences or drawing conclusion about a population based on a sample of data. Common inferential statistics include hypothesis testing, confidence intervals, and effect sizes. So these are some of the this is the main purpose of if I try to be precise, inferential statistic is something that we mostly use in our research, and that is the main purpose of using statistical technique in our research, that we want to draw conclusion about the whole population based on the data that we have collected from the sample. And in order to do that, the kind of statistics that we use, those statistics are called inferential statistics. So there are many types of inferential statistics we will see in our subsequent slides. Predictive modeling also we use. This is when we try to predict about the future based on our past and present data. Okay, so that is predictive modeling. We do not use much in our in the case of research, but then in business and all, this is very common. Then time series analysis. This is based on the type of data we are engaging. Time series analysis is something when we try to analyze the data for a particular subject over a period of time. This is a technique used to analyze data that changes over time. Okay, so time series analysis includes also again different types of technique. Say for example, if you want to study what is the determinants of GDP growth, say for example of India. Now India is the subject here, only one subject, India. Now GDP growth data, say for example, if we collect for last 50 years, what was the GDP, how the GDP had changed over the last 50 years, and what are the factors that has influenced the GDP, say for example inflation, FDI, or anything. Okay, so what are the factors that have influenced GDP over the period of time? If we want to study, then what we will do for one subject, that means India, we will collect, say for example, last 50 years data, and that is called time series data. Okay, so subject is one, but data is collected over a long period of time. So time series analysis are those statistical technique in which we can do that kind of investigation. Longitudinal data is slightly different from time series analysis. Here we collect data on multiple times. Okay, so for example, if we collect data from 100 respondents, say for example 4 or 5 times, what is their, say for example, what is the lifestyle of a particular community? We have selected some sample, and in the interval of 3 years or 4 years or 2 years, we are collecting data in multiple phases in time. That is the kind of data which is called longitudinal data, or it is one of the variation of this is panel data. Say for example, if we select 1000 listed companies of India, and if we collect data for those listed companies for next say for example for last 10 years, then there is 1000 company, and data is collected for 10 years, so it is altogether 1000 multiplied by 10. So that is also that also falls under the longitudinal data. So for this, we have a different set of analysis which we call panel data analysis, like fixed effect model, random effect model. Those things come under this. So this type of analysis involves analyzing data collected over time to study the pattern of changes and stability. So if I collect data on the lifestyle of people of a particular community, say for example, over last 20 years, okay, over last 20 years, every year I go to that particular community, I collect data from them regarding their lifestyle. So over last 20 years for the same community, if I am collecting the data, and then if I try to see how the how the lifestyle has changed for the community during the last 20 years, that will fall under the longitudinal data analysis. Okay. Last one is multivariate analysis. This type of analysis involves analyzing multiple variables simultaneously to study the relationship and pattern. So multivariate analysis is one of the very powerful tool where we simultaneously try to see how different variables are connected to each other. Say for example, if we are talking about say for example, behavior, attitude, awareness, all these variables, how they are connected to each other, how awareness is connected to behavior or attitude, how attitude is connected to behavior, or say for example awareness. There may be bi-directional relationship also. So if we try to analyze multiple variables, and all the variables are, say for example, interconnected to each other in one way or other, then in that case multivariate analysis is very I mean useful. So common multivariate analysis technique, if we talk about, we have factor analysis. Many of you must be aware about that. Then structural equation modeling is another most important technique of multivariate analysis we use in case of social science research. So these are some broad categorization of different types of statistical analysis we can use. Now under these different types of statistical analysis, we have different tools, techniques. Say for example, under inferential statistics, if we talk about, there are many different tools, okay, many different techniques that we are going to see in our subsequent slide, some of them. Before we go into since we have wasted a lot of time, so I'm going little fast. If you have any queries and all, we'll be discussing at the end of the presentation. uh, Type of data based on measurement scale. This is very important. What kind of statistical technique we are going to use, that will depend upon mostly what type of data we are dealing with. Okay, so based on the measurement scale, there are 4 different types of data, and these data actually reflect the quality of the data. Now at the lowest level of quality, if we talk about, is the category which is called nominal data. It is also called categorical data. Okay, so if you see the explanation of nominal data, data that can be classified into distinct categories with no in-hand order or ranking. So we may have some kind of data which only reflects or only talks about the grouping of data. Okay, but that will not that grouping will not have any kind of ranking or any kind of value. Say for example, if I talk about data on gender of the respondents, you have collected data from 200 respondents. Now what is the gender of those respondents? That is also one kind of data. So in our analysis, what we do, if the gender, say for example, if the respondent is male, we assign 0. If the respondent is female, we assign 1. So here also 0 1 we are dealing with data, but then this 0 1 has no meaning other than it is only the category, whether it is male or female. Okay, so data that is the lowest level of data we can talk about, that is the categorical or nominal data. Now if you see the example, eye color, we have different types of different color. Now can you rank these colors? We cannot rank these colors. This is only category. Then gender, male, female, say for example population, party. So these are different categories which cannot be ranked. Then little bit better than nominal data is the ordinal data, where we can have the categories, but at the same time we can rank them in a particular order. Data that can be put into a meaningful order or ranking, but the differences between the values are not necessarily equal. So here we have one better quality in case of ordinal data, as compared to the nominal data. We can put them into ranking, but then what is the actual difference between those rank, that we cannot assess. Okay, so if you see the example here, education level high school diploma, bachelor's degree, master degree, we can put them into some kind of ranking. Say for example, if I tell you that what is satisfaction, someone may say that satisfied, highly satisfied, moderately satisfied. Okay, so we can rank them. If it is satisfied, 1, highly satisfied, 2, moderately satisfied, 3. But then that ranking, I mean the difference between highly and moderately, that difference should not be equal here. That difference may not be equal. We cannot say that if someone is satisfied and moderately satisfied, we have given the number 1 or 2, the difference is 1, and again moderately satisfied to highly satisfied, again 2 to 3, difference is 1. That one difference has no meaning, because that does not actually reflect their level of satisfaction difference. So this is ordinal, where we can order them, but we cannot tell about the exact difference. Then the next thing comes is interval data, which is again slightly better than the ordinal and nominal data. Now, in case of nominal, we have category. In case of ordinal, we have category plus ranking. In case of interval, we have category plus ranking plus the difference between the ranks. That also we can access. Okay, so data that can be put into meaningful order or ranking with equal intervals between the values, but there is no true 0 point. Now that is the limitation of this data, that there is no actual 0 point. The origin, that 0 point is missing. Now if we talk about temperature, now temperature, if we say that today is 25 degree, okay, and tomorrow is 30 degree, the difference we can say, okay, there is a 5 degree difference. Now next day, say for example 35, there is again 5 degree difference, that we can say. But then can we say something like this, that today's temperature is 20, so if it becomes 40, the heat that we are going to feel, that is going to be exactly double? Or can we say that if the temperature is 0, there is no temperature at all? That is not possible. That means that 0 point, that is missing in this interval scale. So what is the implication of that? We can add or less. Say for example 30 minus 35, say for example 35 minus 30, there is a 5 degree difference between these two temperature, but then we cannot multiply it, we cannot divide it. Okay, so this is one limitation of this interval scales data. And finally we have ratio scale data, which is the highest order of data. If your data is something which is in the ratio scale, then you can apply any kind of statistical technique. Now that data that can be put into meaningful order, ranking, and also which has some kind of 0 point. Say for example, if I talk about income, now my income, if it is 0, means I do not have any income. But if I say today temperature is 0, does it mean that there is no temperature? There is still some temperature. But if I say today's my income is 0, that means 0, I do not have any income. If I say that today my income is 5,000, tomorrow it becomes 10,000, then I can say that tomorrow's income is double than today's income. That multiplication I can do, division I can do, but in case of interval scale, I cannot do that. So this is very, very important to understand. The moment you get the data, what is your nature of data, what type of data you are dealing with, that you need to understand. In case of ordinal and nominal data, most of the statistical technique we cannot apply, which because statistical techniques, they need to fulfill certain assumptions, and ordinal and nominal data does not fulfill those assumptions. So that is why nominal, when the data is nominal, and ordinal, in that case the tools that we can use, that are different. And when the data is interval or ratio scale, then most of the statistical tool we can use. Okay, so this was about the type of data that we are dealing with. Next, we have parametric and non-parametric statistical analysis. So, as I'll not go into the detail of this. Parametric, the statistical tools or techniques that we use in our for the purpose of our research, those can be categorized into two broad categories. One is parametric, another one is non-parametric. Now, the difference between these two is, when we talk about parametric analysis or the parametric analysis techniques, those techniques assume something about the parameter. Parameter means the population parameter that we try to establish or try to calculate in our research. they make certain assumptions about the population parameter. Usually the assumption is the data is normally distributed. Okay, but when it comes to non-parametric analysis, that kind of assumption is not there. That means the non-parametric techniques does not make any kind of I mean, they make certain assumptions, but those assumptions are not as strict as the parametric techniques. So parametric techniques, they make certain strict assumptions about the population parameter, but in case of non-parametric technique, those strict assumptions are not there. They have certain assumptions, but those are very simple assumptions. So that is why in order to apply the parametric techniques, we need to check our data very, very carefully. Now requires the use of interval and ratio scale data. Now what does that mean? If your data is interval or ratio scale, then the assumptions, those parametric techniques that they make, those assumptions are mostly fulfilled. Most of the time these interval and ratio scale data, they fulfill those assumptions, and that is why it becomes easier, or it becomes, you know, practical to apply the parametric techniques of statistical analysis. But in case of non-parametric technique, like can be used in case of categorical or ordinal scale data also. So if the data is of lowest order like categorical or ordinal scale, then in that case we can use non-parametric analysis, because they do not make any kind of strict assumptions about the population parameter. So most of the time categorical and ordinal data, they do not fulfill those assumptions. So that is why we do not have any other option but to use the non-parametric technique of statistical analysis. More powerful, when we talk about parametric analysis, the temptation is always we want to use the parametric analysis. The reason is very simple. Parametric analysis is more powerful than non-parametric analysis. Okay, so more powerful than non-parametric test, provided the assumptions that we are making regarding the data, those are true. Then in that case it is always better to use parametric analysis. But if those assumptions are not fulfilled, then it is better to use non-parametric analysis, because if we use non-parametric analysis, that will still give us valid or robust results. Okay, so for example, if the assumptions are not fulfilled, but if you are if you are using the parametric techniques, then you will get result. But then those results, to what extent those results are valid or reliable, that will be questionable. Okay, but if you use non-parametric analysis, nobody will raise question about the validity of your result, because non-parametric tools are something which can be used in any kind of data. Now some of the examples of parametric test, we must be aware about this: t-test, ANOVA, regression analysis. These are some of the examples which which can be used, but provided their underlying assumptions are fulfilled. Now non-parametric test, we can see Wilcoxon rank sum test, Kruskal-Wallis test, Mann-Whitney test. These are some of the techniques which are non-parametric in nature, where assumptions are very limited. Now when to use, we can see when the data is normally distributed, parametric analysis. When the data is not normally distributed, we can use. Okay, now one more thing, if the data is normally distributed, that means the data's quality is good. Then in that case we can of course use parametric analysis, but at the same time we can also use non-parametric analysis, because non-parametric analysis can be applied in any kind of data. But if the data is not normally distributed, we do not have the option of applying parametric analysis. We can only apply the non-parametric analysis. Data has to be interval or ratio scale for parametric. Data can be nominal or categorical scale. So parametric analysis is mostly used when the sample size is large. Non-parametric analysis is mostly used when the sample size is small, because there is a high chance that data will not be normal. When the data meets other assumptions of the specific parametric is being ignored. So parametric analysis can be used when there are some other assumptions also. We'll see some of them. If those assumptions are fulfilled, we can use parametric analysis. If those assumptions are not fulfilled, then we have to use non-parametric analysis. Okay. Now these are some of the most common tools I have included here. Though there, if we go on discussing about the statistical technique, there are many techniques, but some of the things which we usually use in our research, these are some of the tools I have included here. You can see under parametric test, we have t-test. Again, t-test can be of different types. It can be one sample, two sample, paired t-test. We have ANOVA, we have regression, Pearson correlation, ANCOVA, MANOVA. These are all set of tests which falls under parametric tools. Now that means if you wish to apply this test, then you need to be careful about the data that you are dealing with. Okay, now if you have collected data, say for example some respondents gender or respondents income level or education level, those are nominal or ordinal scale data. You cannot apply parametric tools there, but those can be applied in case of non-parametric tools. Like in the right hand side you can see we have Mann-Whitney test, Wilcoxon test, Purskel-Wallis, Friedman. So these are some of the tests which can be used under non-parametric tool. So we'll see what are the again, when we see these tools, one thing we need to understand is we need to understand when to apply these tools and what are the assumptions that are required to be fulfilled to apply these tools. Calculation is not not a problem, that can be done with the help of software, so we'll not go into that. So let us see this one. The first we'll see the parametric tools. One sample test. What is this one sample t-test? Compares a sample mean to a known population mean. Okay, so here we'll be collecting, if our objective is something like that, we are going to collect data from only one group of people. Okay, one group, and we want to see a particular population parameter, whether the parameter is matching with the population parameter. Okay, let me give one example related to that. If you see the uses here, you can see compares a sample mean to a known population mean. Now what is the appropriate example for this? So for example, I want to test what is the mean income of a particular community in a particular locality, say for example. Okay, now what is the mean average income of a particular community? Now I have selected a particular area, and in that area, say for example there are 1000 people residing. Okay, now I cannot go for collecting data for all those 1000 people. I have randomly selected 100 people out of those 1000 people, and I am going to ask what is their income. Okay, annual income or monthly income, whatever income, or daily income, whatever it is. So I'll be asking them questions about their income, and I'll be collecting data on that. Now I want to test whether the average income of that community is 30,000 per month. Okay, now what I'm making here, I have only one group of people, that is a particular community. I have collected data from those 100 people that I have selected. Now my hypothesis, that is I am making the average income of that particular community is rupees 30,000 per month. Okay, so now after collecting the data from those 100 people, I have observed that the average income, I calculated the average, and I have observed that their average income is coming 31,000. Now I have made an hypothesis that the population mean should be 30,000, but my actual data is showing it is the income is 31,000. Now whether this difference, we can see that there is a 1,000 difference in the average income. Now whether this difference is by chance it is coming or it is actually higher, that we can use, that we can find out with the help of one sample t-test. It is called one sample t-test because we are dealing with only one sample, one group of sample, that is a particular community. Okay, now we are collecting data from that community and we are matching with one expected mean, expected average income, that I am thinking that this community will have this much of income, 30,000, say for example. So that is one sample t-test. Now we can give another example also, like if I want to know what is the mean height of say for example Assamese people. Okay, mean height of Assamese people. Now my assumption is I'm making an hypothesis, the mean height of Assamese people is 5 feet, say for example. Now 5 feet. Now how to test that hypothesis? I will select sample of, say for example, 500 people from Assam, and then I will measure their height. After measuring their height, I will find out the average of that height. Now that average, say for example, it may come 5 feet exactly, it may come lesser than 5 feet, it may come more than 5 feet. Now whether it is actually 5 feet or more or less, that we can test with the help of one sample t-test. Now underlying assumptions, there are many assumptions, but I have included only important assumptions: normally distributed data and independence. Normally distributed data means the data that we have collected, that means height data of the population is normally distributed, and independence means, say for example, if I have collected data from 100 people of that particular community, the relationship there should not be, say for example, those 100 people are A, B, C, D, Mr. A, Mr. B, Mr. C, like that. Okay, now the income of A should not be related to income of B. Income of B should not be related to income of C. So the data should ensure that there is no interdependence among the data that we have collected. So it should be independent. That means A's income should be independent of B's income. B's income should be independent of C's income. That should be ensured. If because of certain reason, if we find that no, there may be some relationship between A's and B's income, then we have to modify this test. Okay. Next comes two sample t-test, where instead of one sample, we collect data from two samples. Now, instead of one community, if I say I'll be collecting data for two communities, and I'll try to see if there is any difference in mean or average income between the two communities. Okay, so now I'll be collecting data from two set of people: community one, community two. 100% from community one and 100 people from community two. I'll be collecting their information about what is their monthly income for both the communities. Then we'll see if for community one, say for example, the average income is coming 30,000. For community two, average income is coming 33,000. Now there is a difference of 3,000. Whether this difference is due to chance or coincidence, or there is actually some kind of difference, that can be tested with the help of two sample t-test. Okay, in the first example, we have only one sample and we have compared that with some hypothetical population value. In the second one, we are not making any hypothetical population value, rather we are collecting data from two group of people, and then we are comparing whether both are same or there is a difference between two. Again, there will be some assumptions like normally distributed, both the groups, in homogeneity of variance. What is the variation in the data for both the group? That variance should be more or less similar. That is homogeneity. Okay. So, for example, for group A, community one, we have collected data from 100 people. Now, income may vary. Someone has 10,000, someone has 15, someone has 20, 30, like that. It may vary. Now, that variation, what is the variation in community one data set and what is the variation in community two data set? Both should be similar. That is homogeneity. If that is not similar, that is called heterogeneity. And sample should be independent as usual. Data should not be connected. Then we have paired or related sample t-test. Here, paired sample t-test means if we compare sample, data of two samples, but those two samples are related to one another. Okay, those are not independent. In the second one, the data two samples were independent of one another, but in the second one, third one, in case of paired t-test, the samples are connected to one another. The example that I can give here is, say for example, I want to see whether taking some remedial classes will have any influence on the marks or scores obtained by the students. Okay, so what I can do here, say for example, I have a class of 30 students. I'm not giving them any remedial class. I will take a test for them. I will obtain the score of those tests, of that test. I'll note it down. Then I will give them remedial class for 1 month maybe. Then after that again I will take some test and I will note down the score. Now I will compare whether there is a difference in the scores obtained by the students before and after the remedial classes. Now if you see here, the sample of 30 students, that is remaining same, but I am comparing before and after. Okay, so that is called paired sample. So here examining, if you see the example, examining if there is a significant difference in test score before and after an intervention. Intervention here is my remedial classes, or comparing the effectiveness of two different treatments. So if you see the sample here, sample is related. In the first case, before the same 30 students, after also the same 30 students. So that is called related sample t-test. So if your objective is something like that, then you should not go for two sample, means independent sample t-test. You should go for the paired t-test. Okay. Now comes the ANOVA, analysis of variance. even though it is mentioned that analysis of variance, here actually we try to see if there is any difference in average value. Okay, if there is any difference in the average value among different groups. In the t-test, what we have done here, in case of t-test, we can compare the average value between two groups. The moment it goes beyond two group, then we cannot apply t-test anymore. In that case, we need to apply ANOVA. That is the difference between ANOVA and two sample t-test. Say for example, if I want to compare the average income of three community in a particular locality, then in that case, community 1, community 2, community 3. Since it is more than 2, we cannot apply the t-test anymore. We have to apply ANOVA. So same kind of what you call the assumptions, underlying assumptions will remain. Just in place of two groups, now we are having more than two groups, and it can go on, like it can be 3 group, 4 group, like that. Okay, so mean average income of 3 communities, that is we can test with the help of ANOVA. Then I'll first explain this ANCOVA and MANOVA, then I'll go to regression and correlation. Okay, if you see ANCOVA, in case of ANOVA, what is happening here? We are comparing the population mean for more than 2 groups, but we are not controlling the impact of other aspects. ANCOVA is something which is called analysis of covariance. Here also we will compare the, say for example, now what is the average income of a particular community? That average income may be influenced by many factors, like what is the education level of that particular community. So when we apply ANOVA, we are not giving any consideration to the education level. Okay, but that is not again appropriate, because if we can control the impact of education level on the income, then we will get more appropriate result. So ANCOVA is a technique which gives that, which makes it possible. That means when we are comparing the average income of 3 communities, then when comparing that, we can control the impact of other variables which can have influence on the income of that community. Say for example, age can be controlled. We can also control the education level of that particular community. If we try to control them while comparing the average income of the community, then ANCOVA is the most appropriate technique. If you see the example, examining the effect of a treatment on test score while controlling the age and gender. So in my previous example, if I want to see the impact of my remedial classes on the test score, then I can also control the impact of age and gender with the help of ANCOVA. Next comes the MANOVA, that is multivariate analysis of variance. Now in the previous two examples, in ANOVA and ANCOVA, we were talking about only one dependent variable, difference of only one variable, that is the average income. Now if we are dealing with multiple variables, multiple dependent variable, then in that case MANOVA is more appropriate. Say for example, if I give example of my tuition, my remedial classes, what is the impact of my remedial classes on the score obtained by students? In the previous case, I was talking about the score of one course only. If I say that score obtained by students in science, maths, and say for example social science, now I am talking about 3 scores. So here, instead of one variable, dependent variable, 3 variables are coming. Before getting the remedial classes, what was the score obtained by each student in science, maths, and social science? After getting the remedial classes, what is the score obtained by the students in science, maths, and social science? So 3 types of dependent variable coming here. So here we cannot apply ANOVA or ANCOVA. We need to apply MANOVA. So if your objective is something like that, you can apply this kind of technique. Next comes the Pearson correlation technique. I think you must be aware, when we try to see the relationship between 2 variables, the strength of relationship between 2 variables, we can apply Pearson correlation. Now in order to apply this Pearson correlation, the variables that we are talking about, that should be continuous. So we should not be applying this Pearson correlation into some variable which is not continuous. Say for example, if you are dealing with the data where the data is not continuous, like it is some kind of ranking, then you cannot apply Pearson correlation. For that, data should be continuous, means it can take any value. If I talk about my income is something which can take any value. Okay, so if I try to correlation between what is the amount of profit earned by a business, what is the value of sales. Now sales is something which can take any value, amount of profit earned by the company also can take any value. Now if there is any relationship between sales and profitability, that we can establish with the help of correlation. So it will tell us how these two variables are connected to each other. Okay, what is the strength of this relationship, and the relationship, the value that we will be getting, that can range between -1 to +1. If we get -1, that means the two variables are perfectly negatively correlated. That means when one goes up by 1 unit, the next will go down by 1 unit. And if we get +1, the two variables are perfectly positively correlated. If one goes up by 1 unit, the other one will also go up by 1 unit. And if we find zero correlation, that means there is no relationship between the two variables. Now again, this is, since it is a parametric technique, here also we have to fulfill those assumptions like normality, linearity, independence, and etc. But one limitation of this correlation is we cannot say which one is cause, another one is effect. Which one is effect? Cause and effect relationship we cannot say. We can say two variables are related. Now, which variable is leading to change in the another variable, that cannot be established with the help of correlation. Now, if we want to test that whether a particular variable is leading to change in the another variable, for that purpose we need to use regression analysis. So that is the mostly used technique we use in our research, that is regression analysis, where we can see what is the impact of one variable on the another variable. Okay, there may be many different examples of this. It can go on. Say for example, if I want to see what is the impact of companies leverage or capital structure on the profitability. So profitability is the dependent variable here, which will get affected by the leverage. So leverage will have impact on the profitability. So that impact we can see what is the impact of leverage on profitability. But if we simply use correlation, then we will see there is relationship between leverage and profitability, but we cannot say that that impact is done by leverage on profitability, or it is done by profitability on leverage. Okay, that impact we cannot segregate, but then we can only see there is some kind of association. Regression is very powerful tool. If we go on, if we discuss about regression, there are many what do you call, there are many types of regression: simple regression, multiple regression, and within that also panel data regression, time series regression. Then we can talk about instrumental variable regression. So it is a separate topic altogether. But then if your objective is to investigate the impact of a particular variable on another variable, that you cannot establish with the help of correlation. In that case, you have to must go to the regression analysis. So that is why when you frame your objective, the framing, the wording, that is very important. If you simply write to investigate the association between say for example education and income, then you will only see the association. You are not intending to use regression here. But if you write to investigate the impact of education level of income on income, then in that case your simple correlation will not fulfill your objective. You have to go to the higher version like regression. Okay, that those were some of the parametric. Now hello, am I audible? Hello.
Yes, you are audible, sir.
Sir, how much more time I can take?
Sir, it's up to you. Time is not a limit, sir.
Okay, I'll try to finish in 10-15 minutes.
No
Okay.
problem, sir.
Yes. So now we'll see the non-parametric tools that we can use in our research. These are mostly for all the parametric tools. We also have in the similar line some non-parametric tool also. Say for example, the first one, if you see here, Mann-Whitney U-test. This tests the difference between two independent groups. Say for example, in our two sample t-test, what we have seen, if we want to compare the income of two communities. Now, if the data is fulfilling the assumptions of parametric test, we can compare with the help of t-test. But if the data is not fulfilling the assumptions of parametric test, that like the data should be normally distributed, the sample is randomly collected, then there is homogeneity in the variance between the two groups, then in that case we cannot use the parametric test. The alternative is we can use the Mann-Whitney U test, where we can check the difference between the two groups, but we will not check their mean difference. We are going to check the difference in median between the two groups. Okay, so it is the objective is same. We want to see the difference between two groups, but here it is less dependent on those assumptions which we make in case of parametric test. Okay, so that the data in each group are independent. Independence has to be maintained, and the two groups have equal variance. This should be maintained, but normality assumption will not be there. Wilcoxon signed rank test the difference between two related group. Now, in case of parametric, we have seen that there is paired t-test. Now, alternative to that paired t-test is the Wilcoxon signed rank test. That means if we want to see what is the impact of my coaching, or what is the impact of my remedial classes on test score, and if the scores that we have obtained that is not normally distributed, then in that case, instead of using paired t-test, we can also apply Wilcoxon signed rank test. Okay, then we have Kruskal-Wallis age test the difference between three or more independent groups. Now we have seen in case of parametric, we have ANOVA. Now this Kruskal-Wallis age test is an alternative to the ANOVA. When we are dealing with more than two groups, if the number of groups are, say for example, 3 or 4, say for example, the income of 3 communities, we want to see the difference. Now, in order to test that, if we cannot apply ANOVA because of the assumptions, we can apply Kruskal-Wallis age test without any problem. Okay, next we have Friedman test the difference between 3 or more related sample. Now, same thing in case of Kruskal-Wallis age test, what we are doing, we are testing the difference between 3 communities which are independent of one another. Okay, they are not related to each other. But if the sample is related, say for example, if I am trying to see what is the impact of my coaching on the score obtained by students. First stage, without giving any coaching, I am taking a test. Second test, I gave one coaching, and then I am taking a test. Then again I gave coaching, then I took third test. Now there are 3 time period: one before coaching, one after one coaching, and the next is after 2 or 3 coaching. Now in this 3 group test score, if there is any difference, so that can be used with the help of Friedman test. Little bit different from Kruskal-Wallis. In case of Kruskal-Wallis, it is independent group, but in case of Friedman, it is related groups. Okay. Then we have Spearman rank correlation, and the next one is Kendall's tau correlation. These two are alternative to our Culp-Pearson correlation. Culp-Pearson correlation that we have seen in case of parametric test, that relies on certain assumptions. But in case of Spearman rank and Kendall tau, there is no such assumption. So that is why these two tests can be applied in case of non-parametric, under the non-parametric category, and when the data is not normally distributed. So the first one, if you see, this Spearman rank correlation measures the correlation between two variables when the data are not normally distributed. Similarly, Kendall tau also measured the correlation between two variables when the data are not normally distributed. Just a little bit of difference between these two tests. The first one, Spearman correlation, rank correlation, they measure the correlation on the basis of ranking. Okay, what is the rank of different data? But in case of Kendall's tau correlation, they rely on concordance or discordance. Okay, say for example, whether they are following the same pattern or they are following opposite pattern. When one is increasing, whether the other one is also increasing or the other one is decreasing. So how many cases are there when one is increasing, the other is also increasing, and how many cases are there when one is increasing, the other one is decreasing? They see that concordance and discordance, and on the basis of that they find out the correlation coefficient. So both can be used when the data is not normally distributed, but the approach is different. Both can be used. The second one is said that when there is a tie, okay, when there is a tie in the data set, in that case, because we are doing ranking, no, in case of, since the first one, Spearman rank correlation, since we do ranking, we may find that some of the, in case of some of the respondents, there is a tie. We cannot rank them, or there may be multiple respondents in a particular category, okay, in a particular rank. So if there is a tie, then that becomes a problem. So but this candle tau, they do not rank them, so that's why there is no problem of tie. So if we find cases of tie, in that case candle tau correlation is more appropriate, okay, but both can be used. The final one is chi-square test. Chi-square test, when we try to see the correlation between categorical variables, two categorical variables, that is very, very useful in our social science research. Many a times we come across this kind of data set. Say for example, if I say, if my objective is what is the relationship between the age of the students, or what is the relationship between the gender of the students and the scores obtained by the students. Is there any relationship between gender and score or the grade obtained by the students? Now, say for example, grade, we have three categories: A, B, C, three categories of grade. Okay, and gender, we have two, male, female. Now, if we want to see the association between gender and the grade obtained by students, and we are collecting data from 100 students, we'll place them into the table where one side will be the grade, another side will be the gender of the students. Now, if you try to think what kind of statistical tool we can use to see this association, none of the tools will be applicable for that, because here the data is only category. So in this kind of situation, we can easily use the chi-square test. That is very, very powerful tool for this kind of data, and it can be anything. Say for example, in my cases of research, though in my case most of the time I deal with data which are in the ratio scale or interval scale, but still we can apply chi-square, because one more thing, if your data is interval or ratio scale, since that is the highest quality of data, you can bring it down them to nominal or ordinal scale. You can bring them down to lower quality, okay, and you can apply this kind of test also if your data is ratio or interval scale. But it is not vice versa. If your data is nominal, you cannot convert them into ratio, but if your data is ratio, you can convert them into nominal. That is possible, okay. Now in my case also, I have used sometimes this chi-square test. Like chi-square test, say for example, if I categorize the companies into two groups: those companies which are affiliated to business groups or family business, those companies which are not affiliated to business groups, that means non-family business. This is one category, that means the group affiliation, either affiliated, not affiliated. And what is the, say for example, level of what is the leverage status of the company, whether the company is having any debt or not having any debt. If the company is having any debt in the capital structure, say for example, that is leveraged company. If the companies are not having any debt in the capital structure, those are zero leverage company. Now, whether there is any association between group affiliation and zero leverage. Now, if that is my objective, then I can, in one side we have either group affiliated or not affiliated. In another side we have either having leverage or not having leverage. Whether there is any relationship, if I want to test that, I can test that with the help of chi-square test. So I have used that kind of chi-square test in that kind of situation also. So it is very powerful and mostly used in our type of research. So these are the techniques I wanted to discuss. Now, certain more things, once we get apply this technique, we need to effectively communicate also these results. Now these are some of the points we can keep in our mind. Like, we need to know who are our audience. Know your audience. Consider the knowledge level and background of your audience when presenting statistical results. Tailor your language and explanation accordingly to ensure your audience understand the key points. Our main purpose is we want to make our audience understand what we have actually done. So once we get the results, we should not present them in a complicated manner. We should try to present, I mean, lot of information, but then in a simple possible manner. Use of visual aids, we can also use some kind of chart, graph, tables, etc. in order to make the results understandable to the audience. Focus on key findings. When we apply statistical technique, there are a lot of things, we'll get a lot of results, but you need to understand what is the most important aspect you want to communicate. So your key findings should be on focus. When you write your results, you should focus on your key findings. Those things we just need little bit of mention, you mention them, don't focus much on them. Key things you focus more. Provide context, not just write about the results. You need to relate them with your objective, with your research question, with your hypothesis. Otherwise the whole purpose will be futile. Okay, so the context we should not forget. Statistical tool is only means by which we want to fulfill our objective. So many a times it happens that we focus so much on statistical tool that we forget our objective or the hypothesis that we have formulated. So your results should be interpreted by focusing the context. Be transparent. Whatever methods you have used, whatever assumptions you have made, all those things, if any limitations you have came to know, so those things you have to be transparent while reporting. Avoid jargon, use simple language, avoid any kind of technical things that may be unfamiliar to your audience. Define any technical terms are necessary to use. Practice clarity and brevity. That means you should clearly present your results and try to be concise as possible. Many ethical considerations are there when it comes to applying statistical tool. The data that we are collecting from our respondents, it should be informed consent. We should try to maintain the privacy of data, avoid any kind of harm the respondents by while analyzing the data or presenting the data. We should not or collecting the data, we should not harm the respondents. Fairness and impartiality. Fairness and impartiality means we should be objective. Our results, our analysis, our interpretation should not be hampered by our personal judgment. Transparency we should maintain, how the data is collected, what kind of technique is used, those things clearly mentioned. Validity and reliability. Statistical techniques are used valid and reliable. Whatever tools we are using, we need to make sure that those are valid, and for that purpose we need to know the underlying assumptions that they are making. Reproducibility, that means whatever techniques we are using, that should be in a position to be reproduced by some others. Say for example, I am using a technique, and if someone else want to do the same kind of topic in a different context, they should be able to reproduce or replicate the technique, and the results should be able to be reproduced. Data sharing, that is a good practice. When we use some data, we can share those data with others so that they can also verify. First thing is verify that whatever things we are claiming, those are true, and second thing is they can use that for their own research also. Of course they will give due credit for that to the original researcher. These are, I think I can skip also. Major statistical software, I have just made a chart, like these are some of the software we can use for the purpose of analysis. R is very powerful tool, lot of things we can do, but it is sometimes difficult also. SAS is another tool, much better user friendly compared to R. SPSS, for social science researchers, we are mostly aware about it. This is statistical package for social sciences. Next we have Strata. I use Strata most of the time because I get more option compared to SPSS, and it is user friendly also. And when our analysis requirement is not very complicated, we can also rely on Excel. So Excel is also having a lot of functions which can be used. So finally I came to the conclusion. I think I can skip if I summarize. We understood that statistical techniques are very useful in research, but while conducting the statistical analysis, we need to make sure that the data is appropriate for the technique that we are using. Okay, then sample size is also representative of the population, and the interpretation has to be done properly. So we need to have clear understanding about the technique that we are using for the purpose of our research. The major things that we can, if I conclude, these are the major things we can say that we can understand from this discussion, like statistical concept and techniques, some familiarity with some software, critical thinking skill. Critically, especially when you get the results, when you get the data, you need to critically analyze those data, communicating the results, ethical consideration. These things are not very major. Anyways, thank you so much. This is all from my side. So now I'm available for any kind of discussion.
So yes, we come to the end of this workshop, a virtual workshop on statistical techniques for social sciences. And yes, as Ephraim has mentioned in the beginning, we had a slight glitch, a slight problem with the connectivity. The power went out, and we tried to get back, but then the presentation was so smooth, and there was no problem with the presentation. So that really matters. So thank you so much once again, sir, for that wonderful session on statistical techniques. And as I was listening through the presentation, through the session, everything that I heard is so important to researchers in social science, and those tools that you've just talked about are the very tools that you and I are using every day in our research, in writing articles, in our PhD theses. So yes, for those who require the PPT, I'm sure sir will be able to send us the PPT for future references.